Okay, hello everyone. Welcome to another week of the Knowledgeable. Today is week 81. One other thing that is special about today is World Emoji Day. Why? Why? Because if you find the emoji for calendar, it will constantly say July 17th. And today, July 17th. So today, World Emoji Day. So we just spent the past 15 minutes to spam all emojis in our slides that you will see later on. So why do we know such trivia facts? Because we got friends who specialize in nonsense. So okay, for today's sharing and more details and slides, you can check out the link below. And it is COVID season, and everybody is still half locked at home, and half of us are going to the office. And this week is for me to go to the office, therefore I need to wear a mask. But I think we're still, it will keep like that situation for a while, so we will be live streaming most of our events like this. So shouting out to Shopee, oh, I cannot see myself. Shouting out to Shopee and very Kagong office, Ada's office, and is this matching? I don't know. Yeah, great. Okay, this is our logo in our office in the back of me. Also shouting out to Engineer SG for kindly providing us support on live recording and as well as video recording. So please do not record our live streaming. Do not post spams. They are spam, but I think they are bots, so I cannot talk to them neither. We'll just diligently remove all the spam messages. Also, say nice things to each other. If you are new to this, please say hello to everyone. Introduce yourself. Now is the time to greet everybody. Friday night. Okay. We're looking for speakers for August. So most of our speakers share that even though they already choose a topic that they feel comfortable to share about, they're still learning new things by giving a sharing at okay. So if you're finding something interesting, consider sharing with us here. And also the emojis. Oh yeah, today I learned the emojis one added version. The one in middle looks a bit gender neutral, sub-binary. I think that's what message they're trying to send out. So next, Singapore CSS number 53 is happening August 5th. It will be the first Wednesday of August. Like always, we're once again we're also looking for speakers. If you are if you have done anything interesting about CSS, please share with us interesting things in Singapore CSS. Okay. If you want to look for other technical events that's happening in the upcoming recent, you can check out engineers events / engineer.sg/events. And also for past events, there are videos there. The emojis for engineers, if you search engineers, you will see the software engineers with a laptop. Why like that? We're not even touching an engine. We're not real engineers. Real engineers operate on an engine. But if you want the real engineers emoji, you need to search for mechanic. Why like that? No. So for today's topic, we have two sharing. The first one, Yiqin will be sharing with us a bug he finds on Firefox. But furthermore, he is actually sharing with us the process that his thought process pinpointing which bug it is or what could have potentially caused the bug. Personally, I found that really inspiring. And also, if you do not yet know Yiqin, please say hello. He recently joined, not that recent, but still quite recent. And on the first day of his joining, I got my secret source telling me that he's super great at finding bugs. He's like finding bugs that we never realized that are out there on his first day and first week of training. So please look forward to this. And can I have Yiqin here? Let me stop sharing. So Yiqin, you can start sharing your screen.
Okay.
Okay, let's go.
You can see my screen and hear me, all right?
Are we ready? Okay. Yes, please.
Everyone hear me? Okay, cool. Yep, hi everyone, I'm Yichin. So yeah, I just joined, not recently, but beginning of this year. So yeah, so this was about, I mean, you can listen it as like a story of how I pinpoint a bug in Firefox. So a bit of backstory first. So what happens is, at that time I was like serving on some forums. I'm not sure how many of you are still using forums, but I was serving forums on my phones. I mean, after one of our colleagues, Kenrick, tell us that, you know, Firefox is superior. So that's why I use Firefox on my mobile. I try it out. So I was using Firefox while serving a website, and then I found that something is wrong. Like when I try to scroll the page, then something is wrong. So and I try out Chrome immediately, and Chrome is working fine. So there are some issues with Firefox, but I think it's not that serious. But then I will talk about how I find out more about this bug. Yeah. So yeah. So what is this bug about? So here is some code sample. So on the left, you can see the HTML code, which is a list, any list, unordered order list. I did try with div and other elements, but it seems that only the list will have this issue, but I'm not sure why yet. So in one of the list item, I set a opacity of any arbitrary amount. And inside this list item, I set a fixed position element. So yeah, as you can see from the CSS code, I also set some pointer events and stuff. Oh, by the way, if anyone of you want to like go to the future, you can just go to the link with Firefox, then you can try the bug yourself. Yeah. So so the render output should be look like the right hand side, item 1 to item 8. Yeah, you can see the list. Yeah, this all. Yep. So what happens is that when I have this list of items, right, I try to scroll the list. Then the expected result should be something like this, like everything just scroll together. Oh, by the way, the item 5 I highlight so that it's easy to know which one is the one having issues. But when I try to scroll on Firefox, what happens is this. So, well, but the thing is that the fixed position item is the children of the list item, not the list item itself. So what caused this list item itself also move as in fixed position? So that's the weird part about this thing. And some of you might know that like when you have opacity here and there, then you form a new stacking context. So maybe it's somewhat related to that, but first we have to still find out and reproduce it first, right? So actually, when I first found this thing, I'll just go through about my attempt of finding the fix or the issue with this position fix and this item issue. So the first thing is I try to reproduce in code sandbox. So usually when you find a bug, right, then what happens is that you want to reproduce with the minimal dependency. So let's say if you are using React, you have to remove React first. So you try to make a minimum reproducible code sample so that you are able to actually know that which point is going wrong. Like it might be a library, it might be anywhere else, but now we know it's a browser issues. So after I done this, then the next thing is I just test on code sandbox. I test this code sandbox on a Firefox stable and beta. Because I was thinking like, you know, I want to try different version first, right? I cannot make sure that maybe this is already fixed or something. So I tried on Firefox stable and beta, and yeah, I actually can reproduce this whole thing. But the thing is that maybe it's already fixed. So I just go through the Firefox bug tracking system. So they have this tracking system like GitHub issues, where you can search for different issues that other people have reported. So I found that there's so I searched scroll. I mean, because it's related to scroll, right? Maybe somewhat so after I search a scroll, the thing is that there are like thousands or even more of relevant results. And you can see from the ID itself, there's like millions of bug reported in so many years, like about 10 plus to 20 years of Firefox. So it's like there's so many things that's reported that it's very hard to actually find out which one is the one. So I try reading slowly, like sort by the last updated time and search by the component, this and that. But still, I cannot really find anything related about the issues that I'm facing. So, but in the progress of looking at other tickets, right, what happens is that I just found that I actually miss out one thing to test. I mean, some of the Firefox Pro users will know that I miss out one version of Firefox to test, which is the nightly view. So I just test on the stable and beta. So maybe the nightly view already fixed this thing. Who knows, right? So I just downloaded nightly view and then quickly just build the just run the thing on the code sandbox. But what happened is actually I cannot reproduce the same thing on the nightly view. So that means it should be fixed somewhere between the beta and nightly, right? So it's about one version ahead. So, but how do I know which exact version? Like, because nightly build is being built every night. I mean, as the name sounds. So, but or which commit that actually fix it. So that's the hard part because um uh I cannot find this ticket in the Bugzilla, but it's already fixed. So I'm trying to still look out for how it actually happens. So the first thing is I go to their repository. I look at all their releases, all the nightly build release, and then I find the difference between different build versions. So there's this thing is like the git diff, where you can diff between two different commits, right? So it's the same thing. You can diff between two different revision to see the changes between them. But although it's just a one version ahead, right? But that means like thousands of commits or even more. So I mean that's reasonable because Firefox is like a very complex and complicated things. So I was like, okay, maybe this is not the way that I should go for. I try to search for like keywords like scroll, list, fix, pointed events or things like that. But the thing is, I can't really find anything interesting, especially the list is so long. Like maybe it's phrased differently in their way because I actually haven't read any Firefox code before, not even one line. So that's actually like I cannot really pinpoint what actually goes wrong and what to search for actually. Like other than all the scroll and all the knife keywords that I can think of. But then I think about one thing. What about thinking as a black box? Just download all the old nightly builds that they build every night and then test it one by one. So what happened is that Mozilla actually have this website that actually gives you download all the nightly build all the way back to 2004, all their versions that every day there's like one or two builds for that. So I can just download and then try that versions one by one. But actually, can we do better than just download one by one? Because there's still about 30 versions before the between the beta and the nightly build. So one of the first thing that we learn in uni in the algorithm class is binary search. Yeah. So actually, you can use this binary search thing, which I think Li Ha mentioned a few talks before previously about searching using binary search. So with these 30 plus builds, right, we actually only need log n nightly builds to test out whether which version that already fixed this issue. So that's about roughly 6 times. Then I can find out. So this is actually a huge improvement. And then, so at last I found it is between 25th June and 26th June, somewhere about there. And looking at the commits, it's about 50 plus commits, but it's more manageable as compared to just now a few thousands. And looking at the commits, I found nothing particularly interesting and actually round of idea. I actually tried to read the code, but actually it's very hard for me. I mean, it's some C code, but well, it's been a long time since I last touched C. So I decided to go one step further, other than just using the build version. How about I build the Firefox locally and then use binary search again on those commits instead. So I don't really need to understand about the code. I mean, I just need to try to find out which one is it, then only understand that particular commit. So I clone this Firefox repository and then run this my so-called binary search. I mean, it's binary search lah. And again, it's about 7 builds. Then I find out which one is the issues. But actually, I try another 1 or 2 more times. Actually, I cannot reproduce again wait, what? I mean, I thought like this binary search should be working, right? But surprisingly, it's inconsistent that sometimes I can reproduce, but sometimes I can't reproduce. And perhaps due to some build caches or things like that. And actually, each build, right, is about an hour. So there was already a quite a huge amount of time that's being spent. And this is not including all the times that I spent previously on just trying to reproduce and writing the simple code to reproduce. So I actually kind of gave up. I actually completed my script on what I want to say today in today's sharing, like up to this slide basically about a few days ago. But actually, this is not the end. I decided to just try on Windows because I just tried on Mac, so why not try other OS as well? I mean, that's like the last thing I want to do. I mean, because I already cannot figure out what else to do. Then, but the thing is, it can reproduce even on latest Firefox nightly. Oh, so yeah, so I think this is one step that maybe should do earlier, which is to try on different OS. I actually did try on Android as well, but the Android Firefox nightly build actually also fixed this thing. So, but I just decided to try on Windows. But the thing is that it's the same version, it's just different OS, but why it doesn't work on Windows? And the thing is, I run Windows on a VM. So my first guess is that it's the lack of GPU. So in a VM or in a virtualized environment, right, usually GPU is not virtualized because it's very hard to virtualize GPU unless you have some very fancy and expensive GPU that's being used in data center only. So the thing is that, so I think about maybe it's due to the GPU. So that's why I disable the hardware acceleration on my Firefox Mac, which can, then I can also reproduce the same thing again. So yeah, this is a setting panel. You can see from the screenshot, yeah. So I disable it. Then I can reproduce in any versions after Firefox 48, any versions and any nightly builds. So yeah, so it's due to some hardware acceleration thing that they enable in between the nightly builds that I mentioned that I thought is the fix for this bug. It's actually not. So that's where that I found that it's actually due to these configuration issues. So the fix is not fixing the bug, but just changing the configuration. Yep. So finally, I found this way to reproduce, and yes, submitted to the Bugzilla portal. And this is my first bug found on Firefox, or I mean, maybe the first. Yeah, it is the first of any other browser as well. So I mean, it's quite happy. I mean, well, at first I was like quite sad that, well, I cannot reproduce, like quite frustrated as well. And after I submit this, then one of the maintainer also try out, and then they can reproduce the same thing as well. Then in their comments, right, I just noticed that actually this binary search approach is not new. They also have their own tools that one of the maintainers use in the comments below that which does the same thing. It's called as a Morse regression, which also does the same thing that you given version starting and ending, the good version and the bad version, then they can try to find which version is this bug happens. So yeah, there's actually an automated tool for that. I don't know about that. I just use like the normal naive method. I mean, without knowing all these tools exist. So yeah, with this, then the maintainer is able to reproduce again and again. Yeah, so that's all about it. And if you're interested in, you can check out the ticket. I mean, but there's no fix for this yet. Just that, yeah, I will see how they will fix it. But I think it's quite interesting. This bug, yeah.
Okay, cool. Thank you, Yijin, for this interesting sharing. Okay, let me share my screen. Okay, I have taken my time to fix my bug. So Master Kenrick just told me Firefox correct spelling without the camel case on the second F. Firefox with one word. Yeah, so due to time limit, we have another sharing. We won't do Q&A for this one. If you would like to discuss about this, or if you're interested in learning more about finding bugs tricks, you can find more information about this sharing in this link here. We will also, Ethan will list out, will share with you his slides as well. Okay, moving forward, our next sharing for today, Li Hao will be sharing with us about Monorepo and our Webpack, and also, as Yisin already mentioned, the binary search method. Actually, Li Hao has shared about this in his past arcade talk. It was way back. He did a series on Git good, basically good things about Git. You can check out the video here. So let me pass on to Li Hao. Are you here? Yeah. Okay, we're seeing your screen now. Okay.
Okay.
Go ahead.
So I can start now.
Yes.
Okay, so I assume I can start now, right?
Yes, please go.
Yeah, so hi everyone. Hello. So today I'll be sharing about Monorepo and Our Webpack. If you are from Shopee, you can reach out to me in MetaMost at TanLH. But if you're not from Shopee, you can always find me on Twitter at LiHaoTan. Right. So let's start with today's agenda. Oh, by the way, as we are approaching Emoji Day today, so I was sprinkle a lot of emojis on my slides. So today's agenda will be, we will start with recapping our module resolution and installation, just to make sure that we are on the same page, right? So that we can move on to the next things would be our history with Monorepo and also our Webpack setup, right? So firstly, let's recap on module resolution and installation. To me, right, module resolution and installation is actually two sides of the same coin. Why do I say so? So module resolution is to figure out where your module is when you're trying to import something, right? If you write import from location, where is that file? And installation is actually kind of reverse engineer of module resolution, where I know how you will look for it. So here is where I should put it so that you can find it. And package managers like Yarn, npm, pnpm, they are trying to be getting innovative about doing that, right? So let's recap on module resolution. I think everyone should be familiar with this, but just bear with me. If you are trying to import something that starts with dot slash, right, they will be resolved relatively to from where you are. So imagine you are from this parent index.js. You're searching for this, it will be relative to your path, right? But if you're importing something that don't start with dot slash or dot slash, then what happens is that you will try to look up for the node modules, right? So what it does is that it will recursively looking up for what is where the AA, it will recursively look up for the node modules folder and try to find in each node modules folder where you exist AA, right? For example, if you're trying to resolve for AA from A.js, then you look up from here, from D node modules, C node modules, B node modules, and then A node modules. Right? To prove this point, if you have node modules BB in all different layers, you try to when you import BB from A.js, you will find the nearest one, right? So it is recursively looking up, and it will stop at the first location that it finds the result. Right, so modules, JS modules has like the following capabilities. Like it allows you, like in the modules, you can allows you to export functionalities and also allows you to import functionality from another module. And today I want to talk about is a few interesting quirks that exist in modules that maybe you have to know. Just try to lay them out. So the first thing is module instance is a singleton, which means that if you try to import A and then you import A again, and you try to compare them, they're actually the same reference. They're actually exactly the same reference, right? So, however, if you look at this example, if you're from index.js or A index.js and you try to import C from here, they are actually getting different C.js. Although they are import, they specify the same C, but actually they are getting different files, right? So this is to say that the module instance is created based on the location of the module, location of the resolve module. So where you found it, where you resolve, the destination that you resolve to will be used that as a key for instance. So if you are resolving to a different location, then you're actually getting a different instance. So here, what we can do, if you want A and B getting the same C.js, what you can do is you can be smart, be innovative on knowing how node resolution works. You can actually move that node modules folder up one level, which we call hoisting. You hoist it up one level. Now, A index.js will try to find node modules in A folder, packages folder, D folder, but it found the node module C in the packages folder, and then you will use it, right? Same goes with B. So actually A and B are actually resolved to the same location. So they are the same module instance. Then I want to cover about symlink. So symbolic link, right, is the OS feature where it acts like a portal for file system. So if you have a link and you have an actual location of the file, so whatever, when you look into the link, right, you can find all the files that is within the target location, although you are still within the same link. So you can do similar things. You can have C in somewhere else, but in the node module C.js, you are actually creating symlink instead of actual files, and it points to the same location. So here you are pointing to C.js. Here the symlink is also pointing to C.js, right? So Node.js resolution follows symlink. So it will not actually, when you resolve from this file, you will not get the A node module CJS, but it actually goes to the actual location, right? So in this case, both actual location is actually at packages C.js. So they are getting the same module instance. Okay, so installation, as I mentioned just now, it's kind of like reverse engineer of module resolution, right? And so how we install packages, we use package managers like npm, yarn, and pnpm. So so when we install, because node resolutions will find node modules in a node modules folder, right? So that's why they put packages in there. So so one example I want to point out is that if you have A, if you install A, which dependent on B, which depends on C, which depends on D, then you might end up with something like this, right? So yeah, in this structure, and then the path to D would be A no modules, B no modules, C no modules, D, right? But one thing I want to point out is that some operating system has limit in terms of the file path, such as Windows have maximum path of 260 characters. So you can't really have a two nested node modules folder structure so that your file path may exceed that. In this example, it's 40 over characters. You may think that it is impossible to reach 260, but if you're using Jest, and if you look at the node modules folder, you might have a package called Semver, because it's dependent by Crosspoint, and Crosspoint is installed because of Execa and because of Syn, because of Jest haste map, Jest transform, Jest runtime, Jest Jasmine, Jest runner, Jest test sequencer, Jest config, Jest core. Right. So if you install Jest core, you might have this nested node modules folder structure in your node modules folder, and it's 313 characters long, which exceeds Windows limit. So what to work around this? Well, you use hoisting again. By knowing how a resolution works, we can actually reverse engineer it, right? We can actually make the folder structure to be flattened. So what we actually need to make sure is that D index.js can find C, and C index.js can find B, and B index.js can find A. And in this example, although it's flatter, D can still look up D node modules, A node modules, and then find B, and then find C, and C can also look up and find B. So it still works, right? So you can get a flatter structure while everything still works. So that's the magic of installation. So yeah, try to be fast and to cover all the things. So now we are like even with all the knowledge about how resolution works, how symlink works, how different instances in modules and things like that. Now let's catch up with what we have in Shopee what we have in our Monorepo in Shopee. Okay, so what is Monorepo? So Monorepo is actually a way of organizing clearly defined packages within one Git repository. When I say clearly defined, right, it means that within each packages should have explicitly defined dependency. So it should use package.json to specify all its dependencies. And it also should have a clear boundaries and interfaces such that, so you shouldn't have assumptions on the inner structure of the package. You shouldn't like know whether within the folder you have what file, right? You shouldn't know that. You should just import it as a package as a whole, encapsulated. So so when we talk about Monorepo, we often relates to the tools that allow us to achieve this Monorepo folder organization, right? So the tools usually has two main selling points. It helps us to do two main things. One, the first is to maintain dependencies. What I mean is that if you have package A and package B within your repository, and A imports B, you want to make sure that when you import B, the B that you resolve from A is actually getting the version that is within the repository, rather than install it from somewhere else, right? So yeah, and package management, which means that Monorepo tools usually comes with a suite of tools that help us to publish, version, and run scripts across packages, especially with the understanding of like the dependency relationship amongst the packages. So so when we started Monorepo was actually at late 2018, and back then when we look around, what we have around is we have tools like Lerna and Yarn Workspace, right? So let me talk. So Lerna, let's talk a bit more on. So today I'll be focused more on the installation part, right? To like how these two tools actually help us to install dependencies and link it up within the Monorepo structure. So Lerna actually is built on top of npm and Yarn, right? It actually so when you use Lerna, you can specify your npm client, which is npm or Yarn, and when you're trying to install things with Lerna, it actually uses npm or Yarn to install it for them, but it delegates in a smart way. For example, if you're not using hoisting or you're not using Yarn Workspace, then Lerna will actually try to figure out what it needs to be installed for each packages, what it needs to get from the registry, and then it modifies the package.json. Basically, remove all the dependency that is able to resolve from within the Monorepo, and then it delegates to npm or Yarn to run the installation. And when that's done, it will restore the package.json and then use symlink to link the packages up together. So basically, you have this kind of folder structure. So now I have 4 packages, A, B, C, D, right? And A is depending on B. And because B is within the same repo, B will be symlink. So this will be pointing to this folder, right? Same thing goes with package C. Package C depends on package A. So it's linked to package A as well. But however, for package D also depends on package A, but the version is different from the one that you have within the repository. So what it does is that instead of using symlink, it will fetch it from the external, from registry to get the actual version that you need, right? But on the other hand, if you're using Yarn Workspace or you're using Lerna with hoisting, so if you're using Yarn Workspace, Lerna will just give everything to yarn to figure them out. But if you're using npm, back then without workspace, right? So a learner will have this hoisting option that will do similar things. So what hoisting does is that we'll try to hoist packages A and B because it's being used by the packages within to a higher level, like root node modules, so that it tries to get. So now when you within C, you're importing A, you don't need the symlink, right? You can still resolve upwards and find A, package A, right? So it tries to, so what Workspace does is that it tries to analyze the entire repository and then try to be smart, to be optimal in terms of installing a package. So you try to create less symlink as possible, less external packages as possible, right? Whereas former method of symlink, if you're doing this way, you can actually don't need a bird's eye view of the entire repository. You just need, I mean, you don't have to know all the dependencies everyone needs. You just need to know what are the packages that is within the project, and then you just symlink to them, right? But for hoisting, it actually analyzes all the dependencies and figure out the best possible structure. So when we are trying to do monorepo, we have a few goals in mind. Firstly, is that we want to have a very, very, very clearly defined dependencies, right? So what that means is that package can be easily isolated and removed from the monorepo. Why, if you ask me, it's more of organizational reasons. So each package is more like an isolated feature within Shopee. So if there's like management related changes, we can actually easily take that package away and transfer it to a different repository, right? So what that means is that we make one decision because of this, is that unlike monorepos out there from the open source like Babel, where usually what people do is that they will have build tools that are installed at a root level. Basically, things like ESLint, Jest, they're installed at the root level, so all the packages can use them. But we don't do that. We actually install Jest, ESLint, and all the things for each packages, so that when they are moved, when they are extracted away, they don't have to change anything, and they can just copy and paste the whole thing over to a different repository. So this is roughly what we have in Shopee, right? We have packages, we have different pages, and we have different utils, right? And we so because of the reasoning, because of the goals that we want to do, we chose Lerna plus Yarn instead of Yarn Workspace. So there's like, as you can see, there's symlink and things like that. And why we choose Yarn instead of Yarn Workspace is that we have 3 platforms, PC, mobile, and React Native within the same repository. And what we don't want to do is that we don't want to, every time we want to install, we have to install all the dependency for all the 3 platforms. So that was a consideration that we had at the time, right? So this is what we chose, right? And after we chose this, we have to make sure that we can still build, right? So let's talk about our build tools. Webpack. So Webpack uses enhanced resolve under the hood, right, which implements the node resolution algorithm plus a few niceties. So such as like alias, custom extensions, different main field, like you can specify main module and things like that. Can custom module folder, like instead of node modules, you can have Bower components and things like that, right? It implements the node resolution algorithm so that basically if node works in this situation, our Webpack should work, right? So that's all, right? Or you wish. So let me walk you guys through some of the things that happen, right? So firstly is that we have these XXX utils that kind of relies on React. And when you want to write tests for this package, right, it needs to have React installed so that you can run React. You can run the test with React, right? So usually what happens, if you have this package alone within your own repository, what you would do is you would install it as a dev dependency, right? So you have React installed locally, and then you can use it to test, right? I think that's very common anywhere when you're developing a package, right? But the problem is that when you try to build Shopee right now, and when you import XXX utils, right? Anything, if this utils imports React, it actually resolves to a React in this folder rather than the root node modules React. So you actually resolve to two different instances of React, and that's not good for React. React has to be only one instance, has to be a singleton, right? So what should we do? Usually in this case, right, when you are not having React as a dependencies, you specify as dev dependencies, you kind of expect Shopee, like the users, to install React, right? And it should actually, if this happens, if you actually publish XXX utils and have dev dependencies specified React, it actually still works, because when you install external dependencies, dev dependencies are not installed. You only install dependencies, right? So if this is within Shopee node modules, you would not see node modules React over there. And usually in this case, like React router, where it does need React to do testing, right? So what they usually do is they also specify things called peer dependencies. What peer dependency does is to tell the user that, hey, you need to install React so that I can work, right? So what we decided is we use peer dependencies to mark that we know that React, we kind of hack the notion of peer dependency to tell our build tools that, hey, React over here is not what you are looking for. You should look for the user's React version, right? So what we do is then we try to add a plugin called if peer skip dev dependencies. It's a resolve plugin that basically on a high level, what it does is that it will check the package JSON, check if there's a peer dependency and dev dependency of what you're searching for, ignore it, and continue searching. And if you keep searching up, you would end up not finding React. And you will complain that React is not available. So what we do next is that we add Shopee node modules in the resolve modules list, so that after you find node modules all the way up and you can't find, try the next thing, Shopee node modules, try to see whether React's there. And so that's like our hack, to our fix to make sure that, to find React from Shopee node modules instead, and ignore the one in XXX utils. So I can share a bit on the code of the plugin. It's not that long. Actually, it's just this long. It's quite simple, but I'm not going to walk through the code. You already know the high level of how it works. You can figure that out. So next thing that we encounter after a while is we thought the problem is already solved, and it indeed solved for quite a while. But after a while, it comes back to haunt us when we have more and more packages within our monorepo. So it's kind of a similar problem, but extension of what we fixed previously. So in this case, right, payment utils, as we mentioned, it requires crypto.js and external dependency. And remember previously we used like dev dependency and peer dependency to specify that actually you don't need to install crypto.js. You don't need to install crypto.js in payment utils, and you don't have to resolve crypto.js from payment utils. The user will install it. And at that point, only checkout page needs it. So checkout page requires payment utils. So checkout page installs crypto.js. right? So you have package, this package requires something, but it's a peer dependency, and the user installs the peer dependency for you and installs use as well, right? I think so. That is what we expect to work, right? So there's a reason why we don't put Crypto.js in Shopee node modules, is because Shopee node modules, Shopee is only checkout page that uses this library. So why install it there, but install just at the dependency that you need. So checkout page in future you can take it out whole isolated by itself. You know all the dependency it needs. So logically or structurally, we actually want this to work, but it doesn't work because just recap on how our resolution works. When payment utils imports Crypto.js, it tries to look for the node modules within itself and its parents and its grandparents, right? And it couldn't find Crypto.js because it's a pure dependency. So and then what we do is that we fall back to Shopee node modules, but Crypto.js is not there as well. So what we do, and then so Crypto.js is not there, right? So this is like same old problem, kind of come back to haunt us that you did one hack, I know you. Let me show you something that you didn't encounter for. So what we do is that we figure out that because Webpack uses symlink, so it just function the same way as node modules, right? Whenever checkout page imports payment utils, it actually finds packages payment utils, right? Although this is a symlink, it actually finds this payment utils in packages, and from here you resolve whatever you import from. In this file, whatever you import, you resolve from this location, and you can't find it, right? So if you specify symlink to false, you're telling Webpack that, hey, don't follow symlink. So within checkout page, if you're importing payment utils, you'll end up in checkout page, the modules, payment utils. This is the location that you're resolving to. And from here, if you import Crypto.js, it looks upwards, no modules, and find Crypto.js. So everyone is happy, right? So basically, the hack, the fix is to specify symlink equals to false. But not so fast. If after that we find that we have two packages that requires payment utils, and so the order page and checkout page both resolve payment utils at a different location. Basically, that means that you will have two instances of payment utils. Right? You create modules instance based on the location that you find, right? And because we don't want to follow symlink, the location for these two case is actually different. So what we do is that we kind of research into how Webpack source code works, and then we found out that Webpack has this line where you compare the identifier of two different modules, and it decides whether you should whether these two modules are the same, right? Basically, what happens is that Webpack will crawl each files, and then for each import statement, it creates one module. And then after that, when it wants to bundle it, it compares the identifier of different modules and decides whether they are actually the same module or different module, right? In this case, it's using this method called identifier. And we can actually try to hack it, change the behavior of identifier such that it always points to one location that we know that if it's a symlink, it always points to this location, so that both modules, although the location resolved by Webpack is different, the identifier is the same. So again, we try to write a plugin, Webpack plugin, to just do that, right? Basically, it creates a symlink normal module instead of normal module, and then it instead of returning what is actually resolved, it returns an actual location. So we calculate the actual location from the resource, right? So yeah, basically we do that, and it kind of solved the problem for now. I'm not sure whether what other new problems that it will come out, right? So let's conclude some of the learnings that we learned, right? I think besides the Webpack stuff, we start with we talk about how resolution works, how is a package manager knows how resolution works, and try to be innovative on how to install, how to structure the node modules folder. And then we talk about back in 2018, when we look around, we try to figure out what are the tools that suits us. We try to do some, because of some organizational decision, we decide something, and then because we make a decision to use Lerna and Yarn, and because of that, there are things that breaks with our build tools, and so we have to figure out ways to work around with them, right? And it feels like we and then one workaround, it fixed for a while, and then we realize more problems encountered, and we keep piling more fixes, right? If you ask me whether are we moving to the right direction, I don't know, right? We are still learning, and one thing I want to point out is that back then there's not much tools around, and I think people around the community is also learning, facing the same problems, and tries to come up with tools that solve the same problem that we are facing, right? So we've solved it a very, I would say, Shopee way, right? We solve it on ourselves, but there are also different solutions that's out there. So I think Yarn V2 was released early this year, and I think last week it had announced V2.1, which has this thing called a Yarn workspace focus, which allows you to focus install certain packages, which is one reason that we decided not to use Yarn workspace, is that every time when you need to install, with Yarn workspace, you have to install all the dependency of all packages, but now Yarn workspace comes with a focus install, which is something that we want. And Yarn workspace also comes with a lot of nice tools that we are using Lerna for. Basically, it covers quite a lot of them, right? So my takeaway is that front end world is always changing. We should always keep a lookout on new ideas and new solutions out there. Although we have been piling up a lot of solutions on our own, but you never know if the solution out there is better than ours. Maybe it's our time to change and to be better, right? Yep, that's all my thoughts I have. All the things I want to share. Thank you for listening.
Cool. Okay, so question time. Okay, so for those of you who are still in the live stream, this is when you can start asking questions. We do have one already ongoing discussion. So Sean asked, why does Webpack has to re-implement node resolution itself instead of just using node to do it? And there is already an ongoing discussion, and let me summarize a little bit. So Chen answered that maybe because Node doesn't cover files like CSS. Well, which is true, but still we can. So Sean responded, we can still use Notepad.resolve without a problem. Don't need to re-implement itself. And then the discussion kind of expanded. There are multiple assumptions, but nobody is sure. So we'd like to ask you here, do you have any insights, any thoughts about this question? Like why it does not use Node's resolution module algorithm directly?
So disclaimer first, I have no close connection with Webpack's maintainer, so I don't know what their thoughts have, but I think I can shed a few lights on a few thoughts that I think that may be the reason. So you need to know that the time where Webpack was developed, it was a few years ago, so I'm not really sure how how powerful node resolution was back then versus like Webpack's enhanced resolve. That's for one. For two, so Webpack's enhanced resolve is actually a very pluggable resolver, meaning that Webpack actually builds a plugin system in the resolver, so you can actually change all the different behaviors of the resolver. Uh, so it's not just alias or like things that I mentioned. There's a lot more things that you can customize, or a lot of different behaviors that you can change on enhanced resolver, right? But why would you want to do that? It could be because of your build tools that you had back then when you decided to use Webpack is already have certain constraints that you need to satisfy. Then yeah, a pluggable resolver will help you to suits your custom needs, right? Node resolution is a very fixed algorithm, and you have to follow it instead of customize it. Yeah, that's my answer to that.
Interesting. I kind of feel similarly with you also, because enhanced resolve, I happen to have worked on a project earlier on that tapped into enhanced resolve, where I needed to write a resolver by myself, and realized that, well, first of all, it is once again a very underdocumented project, but then I think we can learn a lot about it by reading the existing source code and learning from there to write our own resolver. But one thing I realized is that if we learn to customize these by ourselves, it actually empowers ourselves to do a lot more things with our packing process. So yeah, we do have more questions. What are your thoughts on Webpack 5 module federation?
Yeah, so regarding that, it's a very new thing, right? So it was actively developed, I think, last year, and it was like announced recently. I can't remember the conference early this year, right? So what are my thoughts is that also similar to our Monorepo situation, early last year, we also, while module federation is being actively developed and being figured out, we also decided to do something like a micro front end, right? Architecture. But back then, this module federation is not out yet, right? So we also similarly tries to come up with your own solution that suits our needs, right? So my thoughts about this is the same thing, where when we need something and we don't have a solution out there, we kind of have to build ourselves, but also remember to keep an eye out what's happening out there, because maybe someone else has a better idea and build a more better solution. And when that happens, we need to know that whether are we still stick with the solution that we have, improve on it, or learn from the external one, or actually just abandon what we built and then adopt to a other people's solution. Yeah, so that's, sorry I didn't explain or talk more in details about module federation itself, but when I found that it announced, that is actually what was in my mind.
That's okay. You can do another sharing on that topic. Okay, I actually have one more question. So right now we are building on top of Webpack. I believe partially because we already have our project set up with Webpack. Let's say if we are setting up a new project where we haven't made a decision on packing yet, will you, like, on your current understanding about the scale of a project and stuff like that, will you still choose to go on top of Webpack, or do you know of other packing engineering tools that can be interesting to look into and can be easier, or okay, I should not use this kind of phrase, but can be possible for us to customize and make it powerful for the sake of that project, like anything else?
to customize?
Or like right now we're building on top of Webpack. We might need to cover a lot of those problems, or try to do micro front end on our own and coming up with our own solution. So is there like a newer hacking tool that already handles some of those problems, and building on top of those can help us build our modern hacking? Or okay, let me simplify this. Any other options out there except for Webpack?
Okay, so if you're talking about bundlers, right? I personally haven't really tried things like Parcel and what's the other thing? I can't remember. But basically, I haven't really tried them. But if you look at the industry like JS community, I think the two most common ones are Rollup and Webpack, right? And usually, what people's recommendation would be you use a Rollup to bundle, say, libraries. If you don't need like very sophisticated lazy loading and all the things, although it's being supported in Rollup right now, but if you don't need all those fancy stuff, you can Rollup is actually lighter than Webpack, and and also plugin authoring for Rollup is actually much easier than Webpack. You don't have to learn all the different hooks that Webpack has. I think like Rollup plugin is just like functions that you just write and you can customize them, right? So basically, these are the two main players that I know, bundlers that I know, and it has been. And you know, like Webpack actually have like a sponsorship for the maintainer, right? So they're actually building this for full time. So I'm not sure about what other bundlers out there, but you need to know that it's not just shining new tools, but you also need to make sure that it's always maintainable, that you can rely on, and make sure that it's getting better and being maintained, right? So of course, there's new things that's coming out on the blog besides bundling, and I think those things are more of for development purposes, right? There's this thing called Snowpack. Snowpack is like actually Snowpack's idea. The first version of Snowpack's idea is very simple. Basically, after you install your dependencies, right? Snowpack actually goes into all the package, all the dependencies you install, and bundles them, like run a build on them on the first time when you try to install it, right? And so after you build it, right, you can actually use because right now browser supports ES modules. You can just use import statements to import them, right? And it should just work. You don't have, so during development, you don't really have to, because if you're using Webpack to bundle them, actually you have to analyze it on every build, incremental build and things like that. But if you use Snowpack, they already build and minimize nicely for you. You just use it immediately. So you can save some times over there, right? And another interesting thing would be called Vid. I think was developed by if Evan Yu. So Vid is also a very interesting concept. So right now, browsers actually supports ES modules, right? And we always talk about we shouldn't use ES modules because the browser supports for like older browsers may not be there. You don't know what the browsers the users are using, but you know what browsers you are using, right? So in development, you can actually use more modern features. So Vid is like it's just a file server. You can think of it as a file server, and the file server can serve all the different kind of code for you. So you can just use ES module to import, say, TypeScript files, and on the fly when the file server serves you the TypeScript file, it does the transpilation and back to just JavaScript, right? And like if you can import JXX syntax while you are getting the file, it's getting transpiled and turns into JS files for you, right? And then you just utilize your browser's module resolution to actually fetch all the files for you, right? So you don't really need, then you don't need to bundle every time when you want to start a dev server. When you start, it's already up. And only when you require that file, it's only that time it gets built, not built, but transpile back to JavaScript if it's not a JavaScript file. But if you're using modern syntax, then you don't even have to worry anything, right? So this is the current landscape of bundlers that I know of. Maybe there are tools that I don't know, I didn't mention. So sorry about that.
That's cool. That's cool. That's already a highly overview of what's going on out there in a mere 4 minutes. Okay, so there are actually more discussions going on in the live chat channel, but we're running out of time already. So what I'll do is I'll leave this YouTube live stream open for a little bit longer, such that we can sort out all the questions in forms of the chat. And so for today's sharing, thank you again for sharing with us about this and participating in this discussion. And yeah, so for those of you who are still in the channel, if you've got questions, feel free to reach out to us in the GitHub issue. And yeah, so that is all for this week's sharing. For next week's plan, I think. Okay, we have Sean in the chat also. So next week we'll have for those of you who know or do not know, Sean has recently published a book. So next week we'll be talking about the book on career development. So if you have questions, if you're curious about what's going on, please look into this context, and you can prepare your questions for the next week's event. Okay, so that is all for today. Like I mentioned, I'll leave this chat open for a little bit more, so you can stick around and chat a little bit more. And then, with all that said, have a nice Friday evening, Friday night, and have a great weekend. And I'll see you guys again next week. Bye-bye.